All right, apparently we're live. This is Barry White broadcasting to you from sunny Fredonia. Yeah, let's just see how sunny it is out there. Yeah, super sunny. Anyway, Google Hangouts keeps telling me I can broadcast for 8 hours, but I'm pretty sure once again that that's a terrible, terrible idea. So let's start this lecture. This is the fourth part of Chapter 7, Regression lecture. This is how to calculate those pieces of the regression equation, because this point, this piece, this step in regression is the part where we just try and figure out what the model is. What are the values that go into this model? And so at this point, we want some numbers. So this is how we figure out those numbers. We want to know for every 1 unit increase in whatever our X value is, then what is our best predicted estimate for the increase or decrease that we would then have in our Y variable. So let's charge through this. You really only need to figure out 2 numbers. So this is going to be relatively brief, I hope. You just need to calculate 2 numbers, and this is going to be a little unfamiliar in some ways, but it's using the kinds of things we've used before, the kinds of numbers we've used before, extremely simple math, and it'll be very simple to figure this out, I think. Excuse me. You caught me at a time when I'm not the healthiest I've ever been, just getting over a cold. So you've got 2 things to find, B and A. So B is the slope, and the textbook calls it B1. I changed it in my annotated version to just B, which is much more common in the social sciences. So we find B first, and then we find A. It's pretty simple. There's actually like a dozen different ways to do this. There are ways to do it starting from just the raw data. There are ways to do it, like if you happen to know this and this, then this is how you figure it out. I'm not really interested in all that. We'll look at one way to do it. And then if you're really interested, you can figure out other ways to do it. We'll do one way to figure out what B is and what A is, and I'll make sure on any exams that I give you enough information to do that. So we leave X in the equation just as the letter X, and Y hat just as Y hat, because the equation just tells us, it always has 2 unknowns. It says, you know, plug in some X value and I'll tell you what your predicted Y is. So you've got to leave those 2 things open so that you can plug in the X and plug in the Y, or you just look at it and you look at the A and the B, and that tells you the shape and this is, yeah, sort of the shape and the status of the model, the size of the model, that sort of thing. So the regression line itself on a graph will always go through the point where the mean of X and the mean of Y cross. So the mean of X will be a vertical line, the mean of Y will be a horizontal line, and there will be one point in the graph where they will cross, and the regression line will always go through that. So you can use that to figure things out pretty quickly and to draw a line quickly if you need to draw one on a piece of paper. So let's talk about calculating B first, which is the slope of the line, which is sometimes called the regression coefficient. In the social sciences, we usually call that B, the raw score version, the regression coefficient, not the standardized one, but the raw one. You need to know the correlation coefficient, the standard deviation of Y, and the standard deviation of X, because B is nothing but the correlation coefficient put into the scale of the 2 variables you're dealing with. Another way to say that is the correlation coefficient is just the regression coefficient standardized. So here's the formula, real easy. Y is over X, and you can remember that with a little mnemonic that the Y axis is up and down, it's vertical, and the X axis is always on the bottom, it's always flat, it's below the Y axis, so Y is on the top, X is on the bottom. So it's the correlation coefficient times the ratio of the standard deviation of Y divided by the standard deviation of X. And what this does is it just takes this scaleless, perfectly standardized thing, the correlation coefficient, and says, what does that look like if you express it in terms of these 2 actual variables? So, you know, you've got your equation here, and you want to fill in that B and replace it with a number. So you just multiply r times sy divided by s of x, and you've got your number. So here's an example. Here's some data. You've got GPA on the x-axis, and you've got exam scores on the y. So you're using people's GPA to predict what they're going to get on a test in a class or something along those lines. So calculating B, here's the data. You can ignore all those individual values. I showed them to you because I want to be fancy, but all you need is the line that has the S's on it and the correlation coefficient. So as long as you've got the correlation coefficient, this is pretty easy. There are ways to do this without knowing the correlation coefficient, but it's much easier if you already know the correlation coefficient. So in this class, that's what we will do. So here's the formula. That's how you figure out B. And plugging in those values, the correlation coefficient is negative 0.397, and the standard deviation of the exam scores, which is y, is 16.592. The standard deviation of GPA is 0.473, so that's what you do. And you end up with negative 13.93. So calculating A now, this is very easy as long as you already know the means of the two variables. A is just the y mean minus B times the x mean. So it's just the intercept. Another way you can do this is if you have enough information, you can just set everything to 0, set the x value to 0, and see what happens with A. So there's a number of ways to skin each of these cats, so to speak. So you've got your equation here, and A is just going to be the B you already figured out times the x mean, that quantity subtracted from the y mean. So back to our example. Here's your data. Now you're going to look at the mean lines. So plugging in the values that we need, it's going to be 74.778, which is the mean of y. Remember, exam scores are the y value here, the y variable here, minus, and remember the correlation coefficient is negative, so it's minus a negative number times the mean of GPA, which I rounded for some reason. I probably wouldn't do that, except that it had a hard time fitting on my screen. In the middle of your equations, you want to round as little as possible and only round at the very end. So working that through, you get 109.47, which is a little weird, honestly. So y hat equals 109.47 minus 13.93x. You remember, some people will put the 13.93x first, so it would be y hat equals negative 13.93x plus 109.47. It's the same equation. If you take those two things and put the second part first, it's still the same equation. It still describes the same line. So there's your y-intercept. It's way up above the 100 range. So you can tell already you're having some issues with extrapolation here. You don't want to extrapolate too much for, okay, if a person had a GPA of 0. First of all, how do you ever get a GPA of 0? I guess I actually have seen a few students who've done that, but those students, well, I think there's something weird going on as far as their relationship to their exam scores anyway. And this is a strange situation where whatever kind of exam this is negatively correlated with GPA. So I don't know what kind of exam that is. Maybe identification of various brands of beer. That was a joke. Anyway, and then here's the point where the mean of x and the mean of y intersect. So if you just want to draw something on a graph quickly, just draw a vertical line up from x where the mean is, a horizontal line over from the mean of y, and then the y-intercept, and take a ruler and draw a line through those things. So there's our best fitting line. The equation that describes it is y hat equals 109.47 minus 13.93x. Now, quick, let's just zip back through here. First, you figure out b. B is just r times s of y divided by s of x. Then a, once you've got b, it's just the mean of y minus b times the mean of x. Ta-da, 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 there you go. Oh, that's amazing. You figured it out. Wow, you're fast. And if you want to draw the line, just so you can have a visual reference, the line means the same thing as the equation. The equation is the line. The line is the equation. The line is the equation put onto a graph. The equation is the line drawn as a mathematical formula. So the point-slope form of the linear equation, you can stop paying attention if you want. I am not going to require this in this class at all. This is something that they really like in the textbook for some reason. This is because they're math people. The point-slope form If you remember that the slope is rise over run. The slope is the change in y for every 1 unit change in x. So in this case, negative 13.93 means every time x goes up by 1 step, y drops by 13.93 points. So every time a GPA goes up by 1 entire GPA point, 1 full letter grade, then our best prediction is that a person's exam score will drop by 13.93 percentage points. So it's rise over run, change in y divided by change in x. So you just have to imagine 2 points on the line, a new point more to the right and an old point more to the left. So the change in y is the y value of the new point minus the y value of the old point. The change in x is the x value of the new point minus the x value of the old point. So then you can take those two quantities, and you've defined change in y, delta y, and you've defined change in x, so you can just substitute those things in. So up here, you've got delta y over delta x, and we've defined what those mean. So where delta y is, you can just plug that thing in there, and where delta x is, you can just plug that thing in there, and we end up with this little equation here. So if the slope is equal to that, then slope times delta x is delta y, right? So that works out. So the way we do this, if you want to figure out your values using the point-slope form, is you pick 2 points. One of them can be the intersection of the 2 means, which makes things fairly convenient. And number 2 can be the point where the line hits the y-axis, another very convenient point that reduces some of the math that, some things cancel each other out. X equals 0, y equals the y-intercept. And then you use this form of the line, and the y0 and x0 are the, as we saw back here, are the old versions. So in this case, things kind of reduce nicely if you use the means of both values. If you plug in the y mean and the x mean, and you plug in the intercept, then that means x is 0 at the intercept, so you can get rid of that. So you can reduce the equation a little. So you have a minus y bar equals negative b times x bar. And there you go. That's the point-slope form of the equation, and that can help you figure out a little more quickly the x and the y values, or sorry, the a and the b values involved. You don't have to know that point-slope business. It's fun because they put it in the textbook, but I'm done. I'm out. Barry White is off the air.